Continuous random variables. Continuous random variables have many applications. Baseball batting averages, IQ scores, the amount of money a person carries, SAT scores, just to name a few. This lesson gives an introduction to continuous random variables and the many continuous distributions. We will be studying these continuous distributions for several weeks. The characteristics of continuous random variables are that the outcomes are measured, not counted. Geometrically, the probability of an outcome is equal to the area under the density of the curve, and each individual value has zero probability of occurring. Instead, we find the probability that the value is between two endpoints, hence the word continuous. We are going to look at two of the simplest continuous distributions, the uniform and the exponential. Some of the properties of continuous probability distributions is that the graph is a curve. The probability is the area under the curve. The curve is called PDF, probability density function. We use the symbol f of x to represent the curve. And f of x is the function that corresponds to the graph. And we use the density function f of x to draw the graph of the probability distribution. The area under the curve is given by a different function called the CDF, the cumulative distribution function. And outcomes are measured, not counted. The entire area under the curve and above the x-axis is equal to 1. Just like it is in probability. And the probability is found for intervals. Remember, that's a continuous part. And then we've got several different scenarios here that I will let you read for yourself, and we will go through these in some of the following examples. In this chapter and the next, we'll study the uniform distribution, the exponential distribution, and the normal distribution. So the following graphs illustrate each of these distributions. This is an example of the uniform distribution with an area between x equals 3 and x equals 6 shaded to represent the probability that the value of the random variable x is in the interval between 3 and 6. Here's an example of an exponential distribution, and here's an example of a normal distribution. So let's take a look at an example.